Section 8.1, understanding angles. So we're going to be looking at a new way of doing angles, and that's called a radian. What is a radian? So what we do is we take a radius, and then we say, well, how long around the circle can one radius go? And that angle measurement is called a radian. So we take the radius, we take that length, we go that far along, and we say that angle measurement now is 1 radian. A radian cuts out a length of the circle circumference equal to the radius. So most of us say angle measurement, we think degrees. So how does degrees relate to a radian? Well, if you look here, if we went 180 degrees, it's a little over 3 radians. And in fact, it's exactly 3.14159, which we know as pi. So in other words, 180 is equal to pi radians. A radian, if we divide both sides by pi, is 180 over pi, or 57 degrees and some change. So this is an irrational number. We would rather use this ratio than ever putting it in decimals. Okay, so this 180 to pi or pi to 180 is going to come into play when we convert back and forth. Okay, so know that the circumference is equal to 2 pi radians. So all the way around a circle is equal to 2 pi radians. Okay, and 2 pi, oops, why isn't this working? So 2 pi radians. So let's say that the radius is 1, so 2 pi is equal to 360 degrees. So if we divide both sides by 2, pi is again equal to 180. So there we go again, another way using the formula for a circle. The circumference of the circle is 2 pi r. Well, all the way around a circle is 360 degrees. I said the radius was 1. So I have also found that radians is equal to pi radians is equal to 180 degrees. So another way to do that. Okay, so throughout this chapter, we're going to use benchmarks and visualizations to do estimation. We want to get really good at estimating rather than calculating. So the measure of angle PCA is 1 radian, calculated in degrees. And we know in our head it's supposed to be around 57 because we just saw that. But we're going to look at Thou's solution. 1 complete revolution is 360 all the way around. 1 complete revolution also measures 2 pi in radians. Remember, that was because the circumference of a circle is 2 pi. Okay, so then pi has to equal 360 over 2. In other words, pi is 180. So to determine the measure of 1 radian, we divide both sides by pi. We get 180 over pi, which if we put in our calculator is about 57.3. Now to visualize it, use an equilateral triangle with a flexible side. I know that 180 is equivalent to just over 3 radians. So it makes sense that 1 radian is just under 60. So we did 180 divided by 3, so it's just under 60, or 57 was exact. I imagine moving the point P along the circumference of the circle, forcing the chord AP to bend to fit until it exactly fits the point A to P1. So I've just moved it and bent it so it fits. So I can see that since PC is moved slightly down, the second diagram must measure a bit less than 60. So because those are close, because we visualized, okay, I just have to move it down a little bit to make that side length fit, I can use 60 as a benchmark, as a good approximation for 1 radian. Okay? So I'm going to estimate each of these in angle measurements. So 90. Well, 90 is half of 180. Since 180 is pi, I can use this relationship to estimate 90. If I rounded pi to 3.2, I can do this easily. So if pi is 3.2 and pi is 180, I want half of that, so that's going to be 3.2 divided by 2, or 1.6. So they decided to relate 90 to 80. So 45 is half of that. So if I took half of 1.6, it'd be 0.8. So it's about 0.8 radians. I can use benchmarks that 1 radian is slightly less, oh, what's C? Sorry, 150. So it's slightly, I can use the benchmark that 1 radian is slightly less than 60 to estimate 30. So what I'm going to do is 150 is 30 less than 180. So 180 was pi, or we said 180 was about 3.2. 30 is about 0.5 because 60 was about 1. So I have 3.2 minus 1, or sorry, minus 0.5 to get 2.7. Okay? So 3.2, 1.7. So that was estimating. So let's look at this. So we did 150. So 150, this is the math, not estimation, but 150 is to what radians as 180 is to pi. So to solve for x, we go x times 180 equals 150 pi. X is equal to 180 divide, or sorry, 150 pi rather. We divide both sides by 180 to get our answer. Let's see what we get here. Calculator, I go 150 pi. So 150, I don't have a pi button, do I? Okay, times 3.14, just an estimation, divided by 180. It looks like I get 2.6, and I had estimated the other way, 2.7. So using estimation is what they want you to do. If you ever want to check, you can always set up a ratio. You go degrees to radians is degrees to radians. Okay, that's a way to do that. I'm going to show you this next one because this is a really neat way to visualize. Determine which is larger, 3 pi radians or 8 radians. So you might say, well, 3 times 3.14, well, that looks like 9, and this is 8. Let's see what happens. Well, 3 pi is equal to 1.5 because we know 2 pi was twice around. So we go 1, we started here, we go once around and another half. Okay, 1.5, sorry. Once around and another half. So 1 revolution is about 6.3. I use the benchmarks. So I visualized this using the minute hand of the clock. Starting at noon, this was 1:30. Okay. 1 revolution is about 6.3. A quarter of a revolution is 1.6. Therefore, 1 1/4 is about 7.9. Yeah, they have, sorry, a mistake here. This should be 1/2. I was reading it and thinking 1/2 is about 3.2. So 6.3 plus 3.2 should be 9.5. Okay, so 8 is a little smaller than 9.5. So in other words, 8 is a little smaller than 3 pi. Okay, and that makes sense a couple of different ways. Then Zachary actually went and expressed these in degrees. Well, 180 is pi, 2 pi is 360, 3 pi is 540. 8 is equal to 8 times 60, because remember we said 60 is about a radian. 8 times 60 is 480. So this was in fact bigger. Okay, so a couple different ways. So 1 radian is about 60 is what he used there. Okay, some of your key ideas. Radian measures is an alternate way to express the size of an angle. And in fact, some of you might have seen radian before when you wrote a trig test. Your calculator was accidentally in rad instead of degrees or DRGs. Okay, And so it was expressing all your answers in radians. So this may have been why you got funny tangent ratios or funny sine angles. Using radians allows you to express the measure of an angle as real numbers without units. So notice we would say just 8 instead of having to say 8 radians, or instead of having to say 87 degrees. The central angle formed by one complete revolution is 360 or 2 pi. Use benchmarks to estimate. And these are some important benchmarks that you might want to memorize. 1 is about 60. 1 radian is 60. Pi is 180, and 2 pi is 360. Decimal approximations can be used for benchmarks for approximate size. So we can look and say, here's some estimations. So 0 degrees could be 0. 90 is about 1.6. 180 is 3.2. 270 is 4.7. This also might be valuable to memorize or internalize to help you with your estimations.